Good morning, everyone. And gee whiz, it's a pleasure to come back, isn't it? It's been such a long time. I've been staring at my Zoom screen for what appears to be years. But no thanks to Tom, none at all. He exposed a little-known secret in the inner cabal of what is the internet, that it's nothing to do with networks. It's nothing to do with routing. The internet is the DNS, and the DNS is the internet. A secret that is normally not leaked, Tom. Naughty. But seriously, the DNS drives everything, which is why I'm not going to talk about it today. I actually want to talk about something at the protocol level. I want to talk about QUIC, because I actually want to give a very quick demonstration of what QUIC is and why it's fundamentally useful. You see, packet-based switching protocols have been around for what seems like forever. And at the time when the internet appeared, it wasn't the only packet switch protocol out there on the internet, out there in the world. Even Cyro had its own version, CyroNet or something. There was DECnet, there was various incarnations of IBM, etc. What made the internet special and what made it so fundamentally different and why you're here today was actually the TCP protocol. Because it's easy to put packets through a network. You know, that's trivial. What's really hard is to create reliable bit streams. And most of the approaches in architecture and networking in the 70s was all about putting that reliability into the network itself. Hi, next hop, here's my packet. Can you tell me if you've got that packet? If you don't tell me in time, I'll just keep on sending it until you tell me you've got it. Then when you say, oh, hi, have a packet and tell me when you've got it. So the entire network was like this message relay service where every single relay was reliable. This is why X25 ran like a dog. This is why DECnet could never go above a few hundred kilobits a second. Because as soon as you try and up the speed, all these tiny conversations just went blur. What TCP did is said, I don't care. Drop the packet, it's not my problem. The endpoints did the reliability conversation. The network couldn't give us stuff. All of a sudden, we had cheaper networks because you didn't care. Drop a packet, forward a packet, same to me. You just didn't care. So networks were cheaper, and you pushed the cost of reliability out to equipment that the network operator wasn't running. That's why IP was so cheap. That's why the telephone companies were finding themselves with a financial nightmare. They were no longer the centre of everything. TCP was the centre of everything. Was. Past tense, because it's all changing with QUIC again. Because QUIC is a fundamental change of the guts of this protocol. Because all of a sudden, TCP and encryption and content are kind of wrapped up in this new thing called QUIC. So what TCP was, as I said, this really nice, reliable protocol that kind of did everything. Common state, end-to-end, sliding windows, wonderful stuff, yep. But there's a whole bunch of things that in the 1980s we didn't think were important. Applications don't have their own TCP stack, or they shouldn't. And indeed, it's really hard to drive your own TCP in that user space because the kernel in most systems goes, no, 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 no. TCP's my problem. I'll look after that for you. You do head-of-line blocking. If I try and do multiple conversations in one TCP session, and this one goes dead, everyone goes dead, because it only has one stream that it's trying to repair. And as everyone with one of these mobile phones knows, when you connect to both Wi-Fi and the mobile network, it's one or the other. You can't use both. Because multipath TCP was actually a really big challenge. And even today, the only one that's tried it seriously has been Siri. It hasn't worked very well. You know, it just doesn't do that. It's not address agile. This is all this hoo-ha about NATs and v4 because TCP doesn't like address changing. In fact, it barfs. You change your address, connection over, reset. So TCP didn't do a bunch of things. At the time, they weren't important enough. End-to-end encryption, someone else's problem. So TCP isn't a bunch of things that are actually important today. Really important. QUIC was a fundamental rethink about the role of transport in today's networking stack. So all of this stuff got wrapped up into a humongous transport protocol called QUIC that swallows all of the services that TCP, encryption, multiple stream, address agility actually did. It's the transport protocol for the 2000s. It's so much more than encrypted TCP. So much more. I can do parallel streams that are independently operated. So if one blocks, the rest still go. It's incredibly quick, no pun intended, because it folds the handshake of, hi, is that you? Yes, that's you. This is me. Let's start doing talking. And the next one that goes, here's the session I want to start with. Here's the session key. Let's do a little bit of handover on certificates. Let's do security. QUIC embeds that entire 5-way handshake into a single 3-way handshake. For short sessions, you've just eliminated 2 round-trip times. It's fast. Because for all those quick transactional transactions we do on the interwebs, QUIC just rams through it. I can do individual flow controllers per flow. If I really wanted, I can run this one on QUIC, that one on BBR, if I'm feeling vicious. You can do all of that inside the application. The host is cut out of the picture. So all of that stuff is now up in the app. And as network operators, where you're used to flow spec and looking at ports and all that kind of good stuff, I know what kind of traffic's on the network, you've just had the blindfold set up. You see nothing. Nothing. Oh, it's a UDP session. Cool. What's it doing? Well, I don't know. Is it between these 2 endpoints? Well, it was, but that one's just changed its address. Whoa. So all of that stuff changes your view of what the network is. It had to. Because if you wanted to move away from TCP and you wanted it to work on today's internet, what possible protocol can you use? You know the whole problem with putting V6 in V4 in that whole transitional thing? Is that a whole bunch of firewalls looked at protocol 41 and said, that's not TCP, that's not UDP, that gets dropped. And so all of these other protocols that we used fell foul of firewalls and filters. You've only got 2 choices. You either run TCP or you run UDP or it doesn't work. So when you're looking at something that's not TCP, you've got to run UDP. Cool. But we still haven't got rid of V4. That'll be decades. I will be dead first, honestly. Just saying. And NATs are so configured that they don't understand what a UDP session is, nor should they. They were never designed to do so. So when you create a state in a NAT that's doing UDP, at any point, it's going to go, internal time has expired, I'm just going to drop this binding and create a new one. So I then assume a new address on the inside. I have changed my address to the other end. And that will happen constantly depending on how aggressive your NAT is. So QUIC solved this by having inside the encryption envelope this thing called a connection ID. Hi, other end, let's agree on basically a token that says every packet with this token is me, even if my source address changes. Ooh. So now, if I present a packet to you, you've been listening to me, but all of a sudden I'm coming up with a new source address, you say, oh, that's the same connection ID. Hey, other end, here's a question, an encrypted question based on this change of address. If you can answer it, it's still you. I will then go to a different source address and just keep on going. So QUIC solves this NAT problem as long as you're not keeping your NAT so aggressive that it changes addresses within a round trip time. It will work just fine, and it does. You can't fragment, which gets rid of a huge problem with IPv6, which can't fragment either, so, yay. Interestingly, it never retransmits a packet. Lost packets are over. Because every packet has a unique ID, you retransmit the data, but in a new packet. Selective acknowledgement gets better because we're having a huge problem with mobile TCP and packet drop, individual packet drop issues. And separately encrypts each packet, so there's no sequencing. So now you actually get what you regard as a modern protocol design, where you sit multiple sessions, multiple individual data streams into one overall session in QUIC, which then becomes packets. So there's a huge amount of multiplexing, and it reflects the design of applications where, as you saw in Tom's presentation with Netflix, dividing up the video stream into a whole bunch of separate components, each of which becomes a separate resource. You can load that into one QUIC session. You can just do the lot inside one session, inside the one encryption form. Incredibly faster and much lighter weight. So all of a sudden, this kind of makes a whole bunch of sense. And by the way, it finally supports remote procedure call. So all of you computer science folk who went, oh, no, TCP never does remote procedure call. True, it doesn't. QUIC does, interestingly, which is what I said there. It doesn't like load balancers. And this is about the biggest problem so far. Because a load balancer sits inside the network and is trying to divide and conquer amongst parallel flows. But with QUIC, all of a sudden I've obscured what a flow is, because I can change one side of the address and there's no port numbers that are visible, and all of a sudden it becomes what looks to the load balancer like a separate session and gets driven to a separate server. And now there are all kinds of folk noodling about this, because the only way we cope with today's content world is by load balancing. And there's a bunch of protocol suggestions, some from Google, some from others, about how to expose certain parts of that connection ID up into the load balancer that kind of goes, I'm not just going to load balance based on the endpoint IP addresses and the port numbers. I'll load balance based on assuming that these connection IDs, which I want some kind of look into, are effectively the same as the IPv6 flow ID. Finally, a use for the flow ID. And that's probably the way that things are going to turn out for QUIC and load balancing. So, you know, at some point this problem has to be solved, but it's not going to be solved anytime soon. At this point, be very careful about the way you design your server networks when running QUIC. Yes, DOS is a problem. DOS is a huge problem, because once you encrypt everything, the other end has to decrypt it in order to understand that it was theirs. So if you're running a QUIC server and I just sent you a bunch of digital garbage, you're going to spend some time wading through that garbage to figure out that that's not real. So all incoming packets need to go through the crypto engine. They need to be decrypted. Now, it isn't asymmetric. This is not a huge amount of work. This is normal symmetric crypto. And these days, you know, ARM and NVIDIA and all those kinds of very fast forms of decryption on symmetric keys are your friend. It's not a super solution, but it's by no means disastrous. We run QUIC servers and they seem to be appropriately DOS resilient without being super good about it. Is enough. We have enough compute capacity to handle it. So QUIC's kind of the protocol for today, because today's world is not about networks and routing. It's not even about the DNS, Tom. It's right up there in the application space. And it's a different kind of application space. Facebook doesn't want Google to know what it's doing. Google does not want Amazon to know what it's doing. And it's not really about your privacy. Not really. No one really cares about you. But what they care about is their commercial competitors in the application space, because your data is the key asset. And if I've spent all this time and money getting it, I'm not going to leak it to Facebook or leak it to any of my competitors. That's my data, and I'm going to protect it even on the wire. That's what we want out of modern transport protocols. So that's QUIC, and that's why this is really, really interesting. It is as revolutionary as TCP was in the late 80s. It is going to be as big a change in our environment as TCP was. So has this already happened? How much QUIC is out there? Well, you know, let's look. Interestingly, there are two ways of doing this. There's the new way, let's just stuff it in the DNS. So there's an HTTPS record that some of you might be using it, more of you should be, where you can say, this is my server, this is my IP address, oh, and by the way, the application level protocol that I want you to use to get to me is HTTP3, otherwise known as QUIC. So you can say in the DNS, use QUIC, I can handle it. The older way, which is how we first started doing it, is you need to go there once. And inside the content, as a content, was an alt service header that says, next time you come to me, don't use TCP and TLS, use QUIC. which is an alt service ID. So the second one only gets visible when you go there a second time. The first one, as soon as you go to that site, you're running QUIC. So first fetch, second fetch. Now, Chrome, and by the way, 2/3 of the planet run Chrome. They just do. And Chrome has been doing QUIC since 2020. There's an announcement from their blog. So you'd think a fair deal should be out there. Interesting. Apple switched over a couple of months ago, or a few more than that now. But they use a different technique. In Safari, they do the DNS. So in QUIC, as soon as you say in the DNS, I can do QUIC, Safari will go, fine, let's just run HTTP3. Let's just run QUIC. So if I'm running a QUIC server, and I've got my session switch and my DNS switch, around, 85% of all the sessions, because Safari is about 20% of the world, maybe 25, and Chrome is around 65% of the world. Add them up. That should be a lot of QUIC. Should be. Cloudflare says, no, it ain't. This is not really current, it's a few weeks ago, but Cloudflare are reporting in Cloudflare's service network on Cloudflare Radar, thank you Cloudflare, it's good to see someone publishing data, around 1/3 of the traffic that they're seeing is QUIC-based. Not 85%, nothing right up there, but it's still 1/3. And what that kind of says to me is that your networks, around 1/3 of your traffic is over UDP port 443. Around 1/3 of your traffic is actually running QUIC. Not 85%, but not 0 either. So we thought, let's put this to the test. And let's not look at traffic, because it's really hard, and I don't run a network. But I have Google Ads. And Google Ads are brilliant. I don't know if any of you really played with the ad networks, but what you realise in the ad network is that you can put scripting inside an ad, and as soon as the ad is impressed, no click required, that script runs. So if I want a program to run on a few billion end devices, your mobile phone, your laptop, and everything else, I just put the shit in an ad and then say to Google, send it. Just send it. And Google says, how much money are you willing to bid? And I go, well, a few dollars, not a lot. And they go, yes, master, I will take your money and send your ad all around the network. So we do about 25 million ad impressions per day. Now, what do these ads actually do? Well, not much. They just say, go to Geoff's server and try and retrieve this URL. Ooh, interesting. What's the DNS like? That's my secret. It's a unique DNS name, so caching won't help you, and I play with the DNS like crazy. So if I want an application level protocol switch in an HTTPS record, of course they can. It's my bloody DNS and I've got control. You're merely the victim. And if I want to run a service on this GET URL, a web fetch GET, I just run up a QUIC server. And there are enough around to make this really interesting. So all of a sudden, I'm getting about 25 million samples a day from all over the internet. Who hasn't seen an online ad? Yeah, right. Even in the Faroe Islands, the poor bastards get subjected to ads. Some of them are mine. So if I do this right, I can actually test how much of the world is capable of running QUIC. Now, you go, well, that should be easy, shouldn't it? Yeah, no. You see, the web folk kind of beat me to it a bit. And there's this weird thing about the cost of setting up a session, which we've known about for many, many years. And the big thing about HTTP2 was it had session server Keepalives. So when we go to all this effort of going TCP, yes, 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 handshake, TLS, yes, 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 session encryption, and then it goes, well, fine, I've delivered your thing. What am I going to do now? You might come back. I'll leave the session open. So if you come back to me within the next server Keepalive seconds, I'll be there waiting. And I won't set up a new session. Default value, amazingly 65 seconds. That's an eon. It's incredible. So if I'm sitting there going, the second time you come to me, we're going to use QUIC, then I need to wait for at least 65 seconds in order to do the flick over. And most of you, it's not that long. So this is a part of the reason why Cloudflare's numbers are so low. Because Chrome uses that form of content switching, And so you trigger QUIC quite rarely because it's a certain kind of application behavior. So we said, well, let's use our server with a customized Keepalive of down around 20 seconds. And then we thought, nah, let's not be pussies. Let's go all the way down to 0 seconds. What happens then? Nothing. It opens a session and says, Keepalive 0 seconds, I'm just going to shut down. The entire server just went invisible. Oops. So, you know, there's a magic number between 1 and, I don't know, about 20 that seems to work better than 65. It took us a while to get that number right. But here's the results of this. Hopefully most of you can see it. We kind of started, is there a laser pointer near me? No, I'll just wave around a bit. We thought about 5% QUIC when we first started this experiment and thought, geez, someone's lying. Cloudflare, somebody is lying. That's just too bloody low. And then we mucked around and looked under various rocks and found it was all about Keepalives. Changed the Keepalive, and then we have this split view. The blue line is the first fetch went to QUIC. And that is Safari browsers on the net. So Safari has globally, as far as I can see, around a 5 to 6% market share globally of browsers, you know, end user browsers on the net. The top red is basically Chrome, which is kicking around, as you see, around 60%. It's massive. Where are they? Here. Green is amazing. Orange and yellow so-so. Red is no. Ethiopia is a no. Iran is a no. In fact, Ethiopia was a yes until they said no. And Iran was a yes until they said no, not going to do that. And then someone must have, you know, caught a flight over, knocked on the door and said, are you serious? And about a month ago, Ethiopia went, oh, yeah, sorry, okay, yes. And a few weeks ago, Iran went, oh, yeah, okay, yes. And so those two are now running QUIC. So what's left? Well, you know, the Great Firewall. Why? Because you can't see anything. Not even server name indications. All the usual metadata peak holes don't exist in QUIC. So nothing is visible. And so the whole concept of this nation-state boundary based on content doesn't work with QUIC. And I don't know what the Chinese are going to do about it. That's their problem. But they seem to be the only area in the world that hasn't gone, yeah, you know, I can see the writing on the wall. Who uses QUIC? I think I've just stolen some of Cisco's slides, but they presented this in May, and I did a screen snap because it's actually a really interesting slide. This is a view of content of network traffic. I think it was an EU operator last year. Biggest traffic component, YouTube. Not Netflix, YouTube. You all watch YouTube. You really, really, really do. And considering that YouTube is a Google product and you're going to Google servers, it's not surprising that the overall majority of YouTube traffic is already QUIC. And I think the reason why the Ethiopians and Iranians sort of folded was YouTube didn't work as quickly, yeah? So make YouTube work again. Okay, good, grumble. Instagram, Facebook, Facebook video, etc. There's an awful lot of QUIC out there in the server world because it's faster, it's more efficient, it works. So let's finish this, and I'll leave some time for questions, about why QUIC really is the TCP of the 2020s. Why QUIC is fundamentally rewriting the relationships within the network and rewriting your job. Because things are changing extremely quickly here. What's going on is that QUIC is now the dominant protocol in the server world. And that's not going away. That is not going away. Because the whole issue about why we put shit in the DNS and why we're using QUIC is that you, as consumers, are pissed off with delay. And the way we get delay out is to eliminate round trip times. Hi DNS, I've got a question. Well, I like that answer. What's the next question? I like that answer. CNAMEs are a waste of time. If I can pack omnibus data into the DNS, so you ask, I answer, the next packet is data, I have eliminated a huge amount of time. And that's good, because then I look lightning fast. So all of this is actually about moving to protocols like DNS, like QUIC, that pack more data in more quickly and give you a much more responsive outcome. Customers see an instant network without worrying about networks and routing and delay. You know, this is just fast. What's QUIC performance like? This is QUIC over Starlink. And interestingly, I'm using BBR as a comparison. If you're running Starlink, does anyone use Starlink? A couple. Don't use normal TCP. It runs like shit. If you really want it to fly, you've got to run BBR because of the latency issues. BBR and Starlink are a marriage made in heaven. It just works, and it works so much better than any other way. But that red line actually tracks what QUIC is able to do over a Starlink connection. It actually works as well as BBR. And part of the issue is, I think, it's really hard to muck around with the packets when you can't see what's in them. So over Starlink, QUIC is just lightning fast. It is amazing. So why are all these service providers running QUIC? Why are all the CDNs switching to QUIC? That second handshake for TLS is a source of endless delay and endless complaint. It just stutters on startup. QUIC is fast. Because QUIC encrypts everything. I know what protocols my network is running. Bullshit. You can't see anymore. I'm going to adjust it such that the most important ports are treated more importantly than all the rest of it. Bullshit. None of that works in QUIC. It's just port 443. There's no data about what the content is. There's no transport control sessions. Who was running those intermediaries that adjusted TCP window size when they thought you were running BitTorrent? Are any of you still doing that? Comcast was caught doing that for a while. You know, it's a pretty standard technique. Does this work with QUIC? Well, no. I don't know what you're doing. So none of that mucking around in the network side to actually try and control user content has the slightest amount of leverage with QUIC. And if you're a 5G mobile provider, this is bad news. This is a declaration of war by the application folk saying to the mobile network providers, game over. If you thought you could muck around with user traffic, it's over. It's really over. You can't do traffic profiling. And I say this in advance of the Cisco presentation because it probably will be question time then. But I think QUIC is so opaque and the ability to hide what you're doing so good that you can't see. And no matter all the AI in the world, it's bullshit. It won't work. You can play a cat and mouse game, but you're always going to lose. And the whole VPN world, Mask, which is VPNs based around QUIC, Apple's private data relay, is not only amazingly opaque, but in work I've been doing lately, it's faster than a direct connection. What? Faster. Which I find quite unbelievable, but you know, there you go, that's the data. So yeah, QUIC is amazingly fast. I don't have to wait for my platform, even if my platform's Android. I don't have to wait for iOS. I don't have to wait for platform services to do QUIC. I can do it in the application. More money, more change, more value is in the application space than the host platform and in the network. So the application's now saying, look, I'm in control of all this shit, all of it. It's my job, stand aside. And that kind of works with the economics of internet working today. So QUIC is an application service, not a kernel service in a platform, and not a service in the network. What does that mean for TCP? Well, it's over. Goodbye. It's finished. It's too slow. It's not flexible enough. It doesn't have address agility. It doesn't have sort of multi-path. It actually is, we're all sick and tired of you guys mucking with our packets, say the application people. So all of a sudden, QUIC just says, look, no more. No more. If you thought you were playing with TCP, keep on playing. We're not using it. The application controls the entirety of the interaction. The application service is now under control of the application, not all these intermediaries, host platforms, networks, etc. So, you know, okay, transition. How long have we been trying to do V6? Give me the closest answer in decades. Why has it taken so long? Because it doesn't matter and it's not economically important to anyone. Because if it did, we would have done it back in 2005. So it's kind of, you really, really should do this stuff that really doesn't matter anymore. Yeah, okay, boring, back to sleep. Why is QUIC already at 30% with a capability of 60% inside a few years? Because it matters. It matters to consumers and it matters to service providers in terms of content and application. The fact that it, is kind of antithetical to network providers, don't care. Just do not care. You're not part of the equation anymore. QUIC does a really good job of hiding content. It does a really good job for the application folk to preserve the data they've extracted from the user and keep it a secret from literally everybody else. Now, the fact that you get some privacy benefits as well, yay. That wasn't the intent, but yay anyway. The intent was my data, my secret, says the application provider, says Apple, says Google, and they're right. QUIC has no dependencies. I'm not waiting for Android to put it into the next release. I'm not waiting for Samsung to wait for 3 years to integrate the latest version of Android into their platforms, yada, 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 yada. It's in the app. It works on my release cycle. How quickly does Chrome release cycles? Every few weeks. All of a sudden, that agility is built in. So how long has TCP got? Months. Not decades, not years, months. It's going to be quick. What does this mean for the internet? Well, if you haven't figured it out already, you were living in a brief moment in time when the network was economically valuable, where transit mattered, where we all talked about peering and exchange points. Conversation over. No one cares anymore. Because all of that economy moved up a level into the application space. Why are Google, Microsoft, Amazon, Apple so valuable? Because that's where we spend the money. The network is sitting there underneath going, please, sir, can I have some money? Because you're unable to actually extract the money directly from the user. The applications are doing this. And so QUIC plays directly into that new economy, that all of a sudden networking is a commodity. I don't care who shifts my totally encrypted datagrams. Or I will treat them with much better QoS than my competitor. Huh? What crap does that mean? Or I will run a VPN for you. Huh? What crap does that mean? There's nothing left to differentiate at the networking level. That job is over. This is like trying to make a competitive service out of road tolls. It really doesn't work unless you're a monopoly. So what's happened now is the networking is now being constrained and confined, and the application space is taking over completely. What does this mean for the internet? Ooh. If you're not already working for Google, it's only a matter of time. And what can you guys do? Oh, God. I don't know. There's no light at the end of this tunnel. Literally, you've been outmaneuvered by abundance of computation, abundance of processing, abundance of memory. The whole reason why we can put the most advanced protocol behaviors into tiny things like watches and get away with it is that the silicon industry outperformed. And it outperformed even transmission. It actually manages to put incredible complexity and state into tiny devices and load that functionality up cost effectively. So we spend our money there, not at the network level. So all of your investments into, better networking, better VPNs, better this, better that, don't care. Just do not care in the slightest. QUIC doesn't pay any attention. So what does this actually say? There's a guy who funded bits of PayPal, who's been around for a while, Peter Thiel. Politically, he's not my kind of person. Trump, Peter, they're out there. But he did say something that was really insightful about the way this industry behaves. We always thought the internet was a poster child of deregulation and vibrant competition. A better job gets rewarded by customers who buy your service. This was the whole model. Not true. Peter Thiel, competition is for losers. Only dominate. And what you can't dominate, commoditize. And so that's what's happening inside the network stack. The application folk have now said, I don't need no stinking telcos, no carriers, I don't even need any hosts. I don't need platforms. This is all about applications. Everything else is commodity. Absolutely commodity. Carriage, lots of options, do not care. Control over the platform. You run Android, it really matters. Well, think about it for a second. How long does it take all of the other providers that use Android to integrate Android, updates into their platform. Years. The application folk go, no, too slow. Way too slow. The browser's going to do this next week. And I don't care what the platform's doing. So control over platform doesn't matter anymore. It's all over. It's now an application world. Thank you.